Hello, and thank you for joining us today as you watch the demo for Streamlining Asset Management with IBM Process Mining. Critical asset events and downtime creates potential risk not only to human life, but also can lead to spiraling maintenance costs and regulatory fines. To avoid that, IBM Maximal Asset Management is a comprehensive solution that helps businesses optimize their asset performance, reduce downtime, and increase productivity. With Maximo, businesses can track and manage their assets throughout the entire life cycle, enabling proactive maintenance, reducing costs, and ensuring regulatory compliance. Maximo's advanced analytics and AI-powered insights provide actionable intelligence to help businesses make informed decisions and improve operational efficiency. From preventative maintenance to predictive analytics, Maximo delivers end-to-end asset management that drives business success. With this demo, we will be reviewing a work order process and using IBM Process Mining. Today, we will be using IBM Process Mining to reveal and eliminate hidden efficiencies, take corrective actions, and maximize ROI across the entire business for the IBM Maximo work order process. The main challenges with keeping organizations from achieving total process efficiency include a lack of transparency into how their businesses are performing. Understanding where improvements like automation will make the greatest impact on cost and customer experience, and the ability to quickly apply process changes. Now, unfortunately, you can't automate what you can't see. Every process leaves a digital footprint, data that reveals how that process is or is not functioning as planned. The challenge is clearly seeing the picture this data creates. Using proprietary AI and machine learning, IBM Process Mining algorithms analyze data from business systems, known as process mining, and desktop interactions, known as task mining. The result is a panoramic view of what's happening, when, and where in your operations. In the following demo, we are going to demonstrate asset management insights for facility managers based on IBM Process Mining. In the first step, we are going to demonstrate business intelligence dashboards and display how they are used to identify deviations from a well-behaved maintenance system and, more importantly, to uncover the root cause of such failures. We will start from a high-level view of the case and continue to guide an in-depth analysis of the reasons behind such non-optimal behaviors. Step 2, we will show the evaluation of possible improvement paths using IBM Process Mining's full insight to action approach, allowing to optimize process performance and reduce maintenance costs and asset downtime. Our story starts one day when the general sites manager decides to see how his sites are performing in their planned maintenance processes. He opens his dashboard. The general manager dashboard contains views allowing the general manager to monitor the performance of maintenance processes in different sites under his jurisdiction. Different key performance indicators such as total amount of cases, average case lead time, average case cost, and site statistics are presented in an easy-to-read manner. One day, the general manager, looking at his KPI summary view, notices that some work order cases take way above average across the sites in handling duration and cost. He looks at the graph showing the distribution of the average lead time and cost per site, where the sites performing below average are marked in red. He immediately notices that both in terms of duration and case cost, the Chile site is underperforming compared to the average. He calls the Chile site manager and asks him to investigate. The Chile site manager needs to investigate why his site is underperforming in planned maintenance KPIs as compared to other sites. He has different business intelligence interactive dashboards to evaluate and analyze different KPIs. He opens a dashboard for the duration KPI. This is a dashboard built specifically for the purpose of guiding a site manager an investigation process of all dimensions which might affect the duration KPI. This dashboard presents the site manager with data to follow on his investigation, starting at a high level view and drilling deeper and deeper, exploring the relevant process data to find bottlenecks and deviations. All parts of the dashboard are interlinked. Applying a filter to see only a slice of the data in one part of the dashboard will filter the data in the rest of the dashboard to the same slice. The site manager clicks on a case status chart to focus only on analysis of completed cases. He then filters to look only at the assets and work orders, which takes longer than average being somewhere around 60 days. Finally, after filtering the relevant assets, he looks only at work orders, which has longer lead times than average. Now he wants to characterize the process behind those work orders. What kind of task takes the longest time? He looks at process case variance and sorts on longest lead times to see what kind of process paths take the longest. He starts going over process representation of those variants to see what kind of tasks are performed in handling those work orders, and to check if some of those tasks violate the duration KPI. He sees that in the variations that have the longest handling duration, the wait for material reception at tasks appears, and it seems that it takes a long time, more than 100 days. Now the site manager knows that this is indeed a long task, but why is it so extremely long in this case? He filters on the activity to continue to look at the data related to this activity only. He looks at the influencers chart to see which features in the data affect the case duration the most. The influencers chart is an AI-driven widget displaying a predictive duration model to outline features which had the most influence on the duration of cases, which include this activity. He sees the asset type and the type of work needed to be done on this asset obviously affect the duration, but more interestingly, the asset warranty expiration period, the asset's end of life period, and asset's commissioning date affect the duration of this activity even more. He clicks on the asset warranty expiration row and sorts by the warranty expiration period. He sees that most work orders in this long activity pertain to assets whose warranty period has already expired. He then goes back and clicks on the asset end of life row and looks at the value there. He sees that most assets are nearing the end of life period. He does the same for asset commissioning dates. So the longest lead times of work order handling processes in this site involve cases with weight of material reception activity, and those revolve around assets warranties that have already expired and are old and are nearing end of life. The site manager looks at the resource distribution chart to see which resources are handling the activity. He sees that there's one person which handles most of the tickets of this type. He talks to this person who informs him that searching for replacement parts for old assets which are no longer under warranty takes a long time. New parts cannot be bought. Since those are old assets who cannot be replaced or are no longer manufactured, and searching for secondhand replacement parts is a long and tedious process, he needs to search for the store's inventory lines, call the stores, and fill out multiple purchase orders. He also tells him the most work orders of this type are assigned to him since he has experience in finding such replacement parts, and therefore it adds to his overload and creates a backlog, which adds to the length of time of handling these work orders. Now the site manager needs to decide what to do with this outcome of his investigation. He now knows one reason affecting his site performance. He needs to decide how to solve the problem. He could train more people to help him with this particular task. He could invest in automation to perform some of the tasks in the activity. He could commission the old assets and purchase new ones. Perhaps it will be more cost-effective than maintaining old assets, or he could try to find another solution to the problem. He enlists the help of his business analyst to investigate the problem further and examine possible solutions to compare the cost and duration optimizations which could be gained by choosing various solutions. Is run, and we can see in the results that the overall average lead time of all work orders in the site is reduced from 114 days to 100 days, a 13% improvement just by adding 2 skilled people to one activity. The cost remains roughly the same since we've reduced the time but added 2 additional resources. The business analyst returns to the original scenario and resets it to the initial stage as an alternative step. He wants to check how adding automation to assist to the activity task would help. Let's say we introduce just 50% of automation ratio to the activity for performing such tasks as filling out purchase order forms and searching store inventories online. Assuming other tasks in the activity still need to be performed by humans, we can see the estimation of how this would affect performance. The simulation is run, and we can see a huge performance improvement, both in terms of the average lead time and cost. We can see that the small change in one of the bottleneck activities identified in some variants of the process affect overall site KPIs. Those simulated KPIs can help to evaluate the cost effectiveness of different proposed solutions for identified bottlenecks, empowering the site manager to make an informed decision on the best optimization. In this demo, we have demonstrated a facility management plan maintenance process. The demo is based on IBM Process Mining Insight to Action approach, investigating the possible deviations and bottlenecks in the process. With the help of business intelligence dashboards built specifically for non-business analyst users, which helped guide this user and his investigation. In summary, we have shown analyses of possible gains of the different solution approaches for the identified bottleneck to improve the overall process by adding digital business automation capabilities to make the process more efficient and reduce overall cost of the task. We thank you so much for taking the time to look at this demo. If you have any questions, please reach out to your IBM Digital Business Automation Specialist for more information, and we will be happy to help you and talk to you more about IBM Cloud Pak for business automation. Thank you.